Can you help us with HVAC too? All right. Good afternoon, everyone. I'd like to thank you all for coming out and thank you for your time. Our team has spent the last several months working on researching a way to design and implement a more efficient and sustainable power generation system for the isolated island of Matinicus. I'd like to introduce you to our team members. We have David McLeish, Jacob Mottram, Ryan Lachance, myself, Amos Anderson, and Teddy Hallett. This is an overview of what we're going to share with you during this presentation. We're going to give you the goals our team established to look into how our team worked together productively and collaboratively. We're going to provide you with our outside resources we contacted to conduct our project and gather information. We'll explain the accomplishments our team achieved throughout the duration of the project, a rundown of our ideal design for a solar array on the island. We'll share our results with you and our gatherings, our recommendations based off our results, and finally, we're going to wrap it all up with a conclusion to clarify our big idea. So let's get into it. What our team was trying to get after in the terms of this project was to formulate and determine the most feasible and cost-effective option to replace the existing power generation system on the island of Matinicus. Matinicus Island would benefit from a cheaper power source that can support their small grid that's isolated from the mainland. Solar power is a very feasible option. It would be most practical for their situation regarding location and the residents' preference, as well as its renewable power source, and would also receive approval from the residents, most importantly. Rising and constant fluctuation of fuel costs, noise issues, repeated power outages, and unreliable generators have increased the need for an alternative solution. The desire of the residents to decrease the cost of power while not having to change their way of life is the driving force for this project. Given the vast majority of island residents are lobstermen, means there's a strong disregard for wind power. With so many power generation sources available today, the residents want a source of power capable of meeting their 24/7 needs without interrupting their way of life. In order to achieve an ideal plan that would meet the residents' power requirements, as well as achieve their stamp of approval, we focused on implementing a solar power supply for the community. Our team established some goals from the beginning that are as follows. Our big idea and goal was to design a more efficient and sustainable power source that is also renewable. By doing this, we would be lowering the fuel costs for the island residents, which was another goal of ours. So we wanted to design a complete off-grid microgrid to replace the existing diesel generators. Our new renewable power source would also reduce emission outputs for this entire community. So these were our broad goals we were aiming for throughout the course of this project. I'm now going to hand it off to Teddy Hallett to come take the stand and talk to you about how our team worked together, the resources we utilized, our accomplishments for the project, as well as our key takeaways. Thank you.
Thank you for the introduction, Amos. As Amos stated, I'm going to talk about how the team worked together, our outside resources, our accomplishments, and our key takeaways of the project. Let us get into it. Overall, the team worked well together. We communicated through group chats, Microsoft Teams, and in person every day. We had meetings in person and on video chats where we determined who was the right team member for each task. Meetings were not scheduled far in advance. We determined that we would have group meetings on a need-to basis. We scheduled meetings one day in advance in accommodation with every group member's schedule. Every member completed their individual tasks in a timely manner, and the team had no issues with anyone slacking. Next are the outside resources the team used during this project. First, I would like to thank Professor Ferreira for her support during this project, as well as Kim and Gary Peabody for being our main sources on the island for power generation and land use information. We contacted multiple companies throughout the duration of this project. Some of them responded, and some of them either did not respond at all, or they were too busy with existing work to help us. The outside resources we used were Maine Commercial Solar, Green Tech Renewables, PV Watts, SunWatts Solar, Iron Ridge, and Tesla. We would like to thank Green Tech Renewables and Maine Commercial Solar for their amazing support during this project. Maine Commercial Solar gave us a quote for a full solar array and battery storage equipment and construction. We used the specifications given to us by Maine Commercial Solar and the PV Watts calculation to outsource equipment from other sources. We found prices from SunWatts Solar for the solar panels and the inverters, from Iron Ridge for the framing for the array, and from Tesla for the battery storage. Green Tech Renewables was the company that we would say helped us the most. They were very responsive and very helpful with giving us information and quotes for a transfer switch design. They designed a way for there to be a solar array that powers the whole island when solar is available, and a switch to utilize the existing diesel generators when solar is not available. Next is our accomplishments as a team. As a team, we found the most affordable way to implement solar into the grid on Matinicus Island. At the beginning of this project, we wanted to find a way to fully power the island with solar, but we found that battery backup was not justifiable for the price. The payback time for the battery storage was too high for the lifespan of the batteries, and we decided the best option for the island would be installing a solar array to power the island and keeping the diesel generators for when solar is unavailable. When we went to the island, we found that transportation of materials to the island would be very difficult. There was a Viking lumber truck delivering building materials to the island, and the truck had a very hard time getting on and off the ferry from the island and the mainland. In addition to that, the truck only had 45 minutes to an hour to drop off all the materials and return back to the ferry. We found the ideal location on the island to place a solar array. The airport has a perfectly cleared area for the construction of the solar array, and when we went to the island, we got to see the cleared area and confirmed that it is usable for construction. Lastly, we found that GreenTech Renewables is the company that we would recommend to construct the array and transfer switch. Lastly, I would like to talk about the key takeaways of the project. We found that battery storage is very expensive for off-grid applications given their lifespan. We found that companies are hard to get responses from when they are preoccupied with tasks for their own company. And lastly, we found that solar power alone is not suitable for off-grid applications in a full community for the price. Thank you, everyone. Now I would like to hand it over to my teammate David, who will talk to you all about the design of the project.
Thank you, Teddy, for the introduction. As Teddy said, I will be going over the project design. On this slide is a picture from our trip to the Matinicus Island. So we purchased ferry tickets and sat through a 2.5-hour boat ride to get out there. Once we had reached the island, we drove to the airport to take some pictures of the proposed solar array site. During this, we also took measurements of the site to ensure that solar array would fit. Picture on the right of this slide shows 2 of the 3 diesel generators currently powering the island. These generators are 480-volt, 3-phase generators running at 1800 RPM, producing 65 kilowatts to 60 hertz power each. The island uses anywhere from 2,000 to 4,000 gallons of diesel a month. The PV Watt quote shows the yearly output in kilowatt hours for the island. As seen in the picture, the island can produce around 305,000 kilowatt hours per year. This quote shows that the island is more than capable of producing enough power year-round. As of current, the island uses a total of 100 kilowatts during peak summer hours. The team chose to place the solar array at the airfield. We chose this area because it's already been cleared for the runway, and it would cut out any cost of tree clearing that would need to be done. When the team began this project, we were unsure of how many solar panels it would take to produce the power needed for the island. As the team began contacting different companies, Maine Commercial Solar and GreenTech Renewables both said that the island would need around 460 modules to power the island. The solar array that the team has proposed is a 225 kilowatt DC system. The direct current system, once it has been transformed into AC power, will produce around 150 kilowatts. Currently, the island uses around 100 kilowatts during peak summer hours. By oversizing the system, even on a not-so-perfect day, the island can still produce power to minimize diesel generator runtime. As seen in this picture, that is our proposed site for the solar array. The area needed for the amount of solar panels that the island needs is around 12,000 square foot. In the picture, it shows an area of around 20,000 square feet, which is already cleared next to the runway. The area is over in square footage for growth on the island in case there's a need for more power in the near future. Another reason the team chose this was because of the close proximity to the transformer that is already on the island. This area is only around a mile away from the existing transformer. To get power from the array to the island without a new transformer, which would be an added cost to the island, a new transmission line is needed. The 2 pictures below show the projected area that the team has placed the solar array. The picture on the left shows an open plot of land next to the pre-existing runway for aircraft to land on the island. The picture on the right shows a concept of what the solar array may look like using an online tool called UBuilder. There are 2 major points that the team has regarding this area chosen. One being that there will be no added cost of tree clearing anywhere for the island. The second being that even with the close proximity to the runway, the solar array will not interfere with the airstrip. The UBuilder tool allows you to create an area so that of your solar project to go on. Once the area has been chosen, the area will be selected and it will fill in any information that you need along with the panels into the area so that the overlay seen on the screen is as close to the real thing as possible. Our next presenter will be Jacob Mottram to talk to you about the results of this project.
Thank you, David. As David stated, I will be talking about the results of the project. Shown is a tax document from Matinicus Island Electric Company for 2022. It is a balance sheet which shows their revenues, expenses, and cash surplus. We found that their fuel costs annually totaled $84,435. Engine repair costs, for the diesel generators totaled $11,409. They receive an annual subsidy of $30,000 from the town. Lastly, the amount of cash surplus they had totaled $227,587. We understand that the company has other expenses besides these, but they will still be there regardless of the power generation source, like labor, for example. This document is what we use as a reference to calculate the payback period for each of the options that will follow. For the first option of a solar array, we have Maine Commercial Solar. We would like to start out by thanking Jason Stuthiet of Maine Commercial Solar for helping us get a quote. He brought to light how expensive battery storage is for these projects. Therefore, battery storage is the reason this option has a total cost of $7.1 million. This included everything for the solar array, battery storage, and installation costs. Jason recommended enough battery storage to last the island 48 hours, which would be 7,200 kilowatt hours. This option has a payback period around 57 years. If they decided to use the cash surplus, it would lower the payback period slightly, but hardly enough to make a notable difference. Battery storage for this scale of a project is not feasible at the moment. The next option we present is sourcing the parts online. This option has a total cost of $5.6 million. For this, we found SunWatts for solar panels, Iron Ridge for mounting brackets, and Tesla for battery storage. For this design, we used Maine Commercial Solar as the company to install the materials. This is where we got our installation costs. We were unable to find one larger battery that is self-contained compared to the previous option where it consisted of multiple batteries. This battery was also designed to supply the island with 48 hours of power. This option is cheaper than the previous, but is still not feasible. Again, with this option, battery storage makes up most of the cost. The payback period for this is around 44 years. Therefore, the battery storage is not feasible for this project considering the circumstances. For the final option, we have Green Tech Renewables. This was the cheapest out of the three because it did not include any forms of battery storage. This option utilizes a transfer switch with a PLC that will start the generators when the solar array is not producing enough power. This option does not completely cut out the use of diesel generators, but it does lower the fuel usage for the island, which was one of the goals for this project. This option has a total cost of around $787,000. Since this option has the lowest cost and still utilizes diesel generators, we evaluated the payback time with fuel savings. The longest payback period for this option is around 14 years if there are little fuel savings and the cash surplus is not used. If 66% fuel savings is considered and the cash surplus is used, then the payback period would be around 7 years. The average lifespan of the solar panels is 25 years, so they will have plenty of life left once they are paid off. This would allow Matinicus Island Electric Company to produce power at a lower price due to their overall costs being lowered. Thank you, everyone. I would like to introduce Ryan, who will be talking about the tax considerations and our recommendation.
Thank you for the introduction, Jacob. With all the results considered, it was obvious to us that the Green Tech Renewables option was the most feasible based on cost alone. Even though the Green Tech option payback time is reasonable by itself, it is important to consider the tax credits recently available that can reduce the payback time even more. As part of a push for clean power generation, in 2021, Congress passed the Inflation Reduction Act, which contained many solar power incentives and tax credits. According to the Office of Energy Efficiency and Renewable Energy, the United States Treasury currently offers a 30% investment tax credit for solar projects until 2032. For tax-exempt entities specifically, such as the Matinicus Island Electric Company, it would be eligible to receive the tax credit in the form of a direct payment. This would translate into enormous savings and reduce the payback period immensely. The worst-case scenario, which is highlighted on top, of not choosing to use any cash on hand and using the tax credit while only 33% fuel savings would still translate into a payback time of less than 10 years. On the other hand, the best-case scenario highlighted on the bottom of using the cash they have on hand, the tax credit payment, and 66% fuel savings annually would reduce the payback time to less than 5 years. Now, we chose 66, 50, and 33% fuel savings to give a range of hypothetical payback times because this option would still use the diesel generators when the solar panels aren't producing enough power. During its busy months, the island uses 15,000 to 27,000 kilowatt hours per month, and according to the PV watts quote that David talked about earlier, the panels will produce enough power during the day to limit generator runtime as much as possible. While the exact amount of fuel saved will vary over time, we decided to give these ranges to give the best and worst case scenario, since fuel use is clearly their largest expense. With the options previously described, we recommend the choice of green tech renewables. This proves to be the best overall choice for the island. If they wanted to rely strictly on renewable power, battery storage would be a great choice. This option would ensure zero emissions. However, it is too expensive to be justifiable. Another thing to consider is that only fuel cost savings and the annual subsidy were used to calculate payback times. This does not include the revenue that the electric company generates, which has the potential to reduce the payback period even more. Because of the Inflation Reduction Act, tax credits would significantly reduce the cost of the project and make the green tech renewables option most desirable. It was also interesting to find during our research that projects like this were done in the past for other islands in Maine, but cited costs as the main reason for them being unfeasible. But with the push for renewables at a federal level and tax credits now available to promote the use of solar, cost isn't as much of an issue and reasonable payback times can be achieved. In this presentation, we went over the problem statement, the goals we had as a team for our project, how we worked together, the many outside resources we used, what we accomplished during this project, the key takeaways that we learned, the project design of the airport being the best possible location for the array, our results which consisted of 3 potential options, and our recommendation of using green tech renewables along with taking advantage of the tax credit to significantly reduce the price and payback time of the project. Thank you all for listening. We hope you enjoyed it and would now like to open the floor to your questions. Yes. Oh.
Hello? Can you hear me? All right, good. Nice job, guys. I have a question for you. Did you happen to look up any of the FAA rules about power production near an airport?
No, we did not, but interestingly enough, we found like when we were at the island, there was a plane there that was taking off because it was one of the mail planes, and it didn't use that land at all there. So we don't think it should be an issue because they took off pretty easily.
That might be something that you want to look up. I think that the EMF can interfere with the radar, so you may want to look that up. One other question. Have you submitted your proposal to the folks at Matinicus yet, and what was their response?
Yes, I actually had a resident from Matinicus that has a point of view on their source of power, and he requested all of our information that we're going to send over after the presentation, and I do believe he may be on the live stream right now.
Excellent. Very good.
Hello. Nice presentation. It was nice. What was the lifespan of the batteries? You mentioned that they were short.
So Jason Stuthia, Maine Commercial Solar, said that for any of the battery projects that he's done in the past, the lifespan of the batteries has been typically around 7 years. So that's why we've come to the conclusion that it's really unfeasible to do, especially for that large upfront cost when the solar panels will outlive the batteries.
Thank you. And then is that airfield, I guess you kind of answered it, is that airfield still used at all, like as a backup airfield, or is it pretty much completely not used?
So the airfield is used every week. It brings mail over and basically supplies for the island. The planes are very small that go on and off that runway, and it's not really an airfield. It's considered an airstrip because it's just like a long dirt road that they land on.
Okay, thank you.
Hey guys, great presentation. I did have a single question. So did anybody research or ask any of the companies about the possibly modified lifespan of both the solar array and the battery packs in relation to being around salt air and having corrosion problems?
Definitely would be salt air is one of the biggest problems with those panels. We didn't talk too much about it, but they said that would be one of the main considerations when putting the solar array in for the salt air.
Y'all already asked my questions.
What is the current condition of the existing generators on the island?
So technically, they have 5 generators right now. 3 of them are in use. And when we went to tour the plant, it was a very dirty and dusty environment, and all of the generators were leaking oil out of multiple crevices. So they're not in the best of shape.
Okay, thank you.
Yeah, could we get the mic to Mr. Jerry Paul?
Great presentation, gentlemen. Teddy, you said in the beginning that you assigned each member by task. How did you go about doing that? How did you go about deciding who was going to be responsible for each task?
So we had meetings to determine that, and we basically said that everything that has to do with the island and contacting the island would be best suited for the people who have contacts on the island, which was me and Amos. And then we split the rest of all the companies that we contacted. We split the tasks up between David, Jacob, and Ryan. Also, every other week, we had rotations, and each person had a different role. So there was like office manager and project manager, project engineer, controller, and each one had a different task when it came to the update that we had to present every other week.
Thank you, gentlemen. Is this working? Thank you, gentlemen, for that great presentation. It's very informative. My question is about those battery packs. I believe they were the Tesla Mega Pack or something like that. Do you know how big each of those battery packs are and kind of the rough footprint of a battery pack that would end up on that island if they so chose to buy one?
So the general size of that battery from Tesla was about the size of a large shipping container. It was all self-contained, and it had all of its computers and stuff inside of the container. And for that battery design, we had 2 of those to supply the island.
Very interesting. Thank you.
I just thought of another question for you. Would the power supplied to the residents be the same price? So to clarify that a little bit, during the day when they were using solar power, would that be the same price as during the evening when they were using diesel power?
Yeah, so we didn't really think about it too much like that. We just more like just tried to do it by the payback time with the diesel cost to pay for itself. And then we came to the conclusion that once the solar panels are paid off, that the rate would go lower, because the electric company there, they're not really a for-profit company, because like nobody really owns them. It's owned by the town. So we figured that once the panels are paid for, that obviously the price would be cheaper, and then it would lower the rate for everyone over time, like for the remaining years of the life after they're paid off.
If there were a different rate, it would promote people using power during the day and even investing in their own battery system at home so that they could charge their own battery system and use that at night rather than the diesel. So just a thought if you move forward. Very good.
Thank you all for coming.